Everybody, my original goal in this problem was to write x as a function of n in this factorial expression. Now, let me just show you kind of where I went with it, and I tried another approach. Notice the definition of factorial. n+1 factorial is certainly equal to n+1 times n factorial. Times n factorial. That just follows immediately from the definition. And that's how we got, or that's how I wrote down this step right here. You see, I replaced n+1 factorial with n+1 times n factorial. And so you get this statement right here. And I wanted to write x as some function of n. You know, we're supposed to find an x factorial such that n+1 factorial times n factorial is equal to x factorial. But I couldn't get anywhere, and so I just decided to work with a special case and see what I could figure out. And I went ahead and just chose n equals 7. The numbers are manageable, you know. So I chose n equals 7 sort of arbitrarily. Now, and you can see what I did. If you follow along, I tried to color code some of this so I don't have to talk too much. But from here to here is nothing more than this statement up here, right? Whereas I'm using this general truth that's easy to discover at the beginning in the general case. This is a special case of it right down here for n equals 7, okay? Now, what did I do? I just applied laws of exponents here on this very next step. Now, notice that 6 squared is equal to 36. And the motivation here was to sort of see if you could make changes or adjustments to make the result look like a factorial expression. So 6 squared is 36, and that's 4 times 9, okay? So I replaced this 6 squared with 4 times 9. Okay, and I did things sort of like that all the way through here. And again, folks, I'm trying to make it look like x factorial for a particular x. Okay, so I got the 9 at the end, you see. So at least we have a 9 at the end. Now right here with the 2 squared, I took one of the 2's away. I took one of these 2's away and brought it to this 4 to make this an 8, right? So you guys can see right here how the 2 squared just became a 2. I stole the 2, put it with this 4, and now we have 8 times 9 at the end. Again, it's looking more and more like a factorial, okay? And in a similar fashion, I did the very same. Right here, I just brought the 7 that's part of the problem really inside, okay? So now we have 7 times 8 times 9. All right, and then you can just see kind of what happens right here. What did I do here to get the 6? I took a 2 and a 3 from here. I took a 2 and a 3 from here to get this 6. Notice I made it color-coded just so I wouldn't get confused. All right, and so what does that leave? Okay, that leaves this expression right down here. We're getting closer and closer. We have 6 times 7 times 8 times 9, which looks like a factorial expression. And again, what sealed the deal kind of right here is that I can take away a 2 and a 5 from here to get this 10 right here, okay? And then that leaves just nothing more than a 2 cubed right here. You see I have a 2 and a 5 that I stole from here, okay? That 2 and that 5 I stole from here becomes this blue 10, all right? And then I'm still left with 2 cubed times 5, all right? And at first I got stuck here, but then I realized, wait, I can break this apart. Look. 2 squared would be the 4 you see right here, and then this 2, another 2 would become this 2. Isn't that cool? So it's just nothing but a bunch of scratching around and manipulation. I don't know how to make this particularly formal, but what we get right here is that x would be equal to 10, right? Remember, we were trying to find an x. Okay, x would be equal to 10 because this expression is equal to 10 factorial. Folks, if you're new to this, technically 10 factorial is 1 times 2 times 3, but you would just leave the 1 out, right? It's the multiplicative identity, right? So we get x equals 10 is the solution here just through manipulation alone. And again, I don't know if there's a closed form for this. I thought for a minute it might be n+3, but that doesn't work for other cases. And so in any event right here, what we get is for the case n equals 7. I don't know what x is in general given an arbitrary n. But I know when we choose n equals to 7, the answer would be x equals 10. All right, folks, so there's your answer for the special case, not what I originally intended. Let me know if you can think of a way to journalize this.